Hi, it's timer time for today. We're going to do 2.6 and 2.7 proof worksheet. I'm actually not going to be doing this live in class, so I just want to make sure I have out there that you can check out the answers to this worksheet if you were absent or if you just want to review the properties that we've been discussing for proof in geometry. So this first example, we're trying to state which property justifies each statement. And it says that 80 degrees is the measure of angle A, and that measure of angle A equals the measure of angle C. Then you can say that angle C is equal to 80 degrees. Well, that property is substitution, or it's actually the transitive property. Even though it didn't do the 1, 2, 2, 3, 1, 3 that we talked about, it still is one thing equals to another, 1, 2. This is 2 and 3. It just didn't go 1, 3. They wrote it backwards. So transitive is really the best answer for this problem. Okay, but I would take substitution. I kind of do take substitution as opposed to transitive on a frequent basis. Some of them are definitely not transitive. They are simply substitution. We'll talk about that when we get to one. RS is equal to 2, then TU equals RS. That's one of our easier ones. It's just when it flips, we wrote down, and that was your symmetric property. Okay, the next one, you would subtract 2 from both sides, so you write the subtraction property of equality. In this one, we would need to add ty to both sides to get from both sides of this equation to get to this. I know it's weird with letters as opposed to just numbers like you're used to from algebra, but using the properties of algebra, we're still doing that with these distances. So it's the addition property. You're adding ty to both sides, and we can write add prop. It is the addition property of equality. The measure of angle 1 equals 30, and the measure of angle 1 is equal to angle 3. Then you can make a trade. It's very similar to transitive property. However, here we have really taken, and well, if you went 1, 2, 1, 3, then this is 3, 2. So it's not really following the 1, 2, 2, 3, 1, 3. We're just taking and replacing the measure of angle 1 with 30 degrees to get angle 3 is 30. So substitution. And I'm going to just get rid of that. It just was trying to show you why it's not transitive. This is substitution property. Okay, now we're going to go through some proofs. This first proof is an algebraic proof, and always the first step is given. That is simply where you're rewriting down what you've been given. Then we do some multiplication, which is not called the multiplication property of equality because we didn't do it on both sides. We only did the multiplication through the parentheses, which we have always called the distributive property. And then we would subtract 3 from both sides. And if you want to write these little steps underneath here, like some of us still do when we solve, that's fine. But the result is that 6 times x is equal to 72. And then finally, what you would be doing is dividing by 6 and getting x is 12, and that's by the division property of equality. What you do unto one side, you must do unto the other. The next proof is another algebraic proof, and all I did with the class was get them started on it, where I wanted to make sure that they correctly did the distributive property on part 2 of number 7. That would give you negative x minus 18. You're multiplying 3 by negative 2 plus 16x, and then equals 12. The next line, all we did was combine like terms. They put together the negative x and the next negative 1x plus 16x to get the 15x. And that was simply combine like terms. And if you wrote simplify, that would be fine. Then we add 18 to both sides, and we got 15 times x is equal to 30, and that would be by the addition property. We added something to both sides. And then finally, dividing by 2 would give us the result of dividing by 15 would give us the result of x equals 2, and that's by the division property. Number 8, first step was given, of course. It's always what's up here. Next, we would, by definition of, there's a hint over here. Definition of congruent segments would tell us to drop the similarity symbol over the equal sign and the segment bars and just write that the distance from A to B is equal to the distance from A to C. At this point, we look at our diagram and we see a 3x plus 15 on AB, so I'm going to make a trade. I'm going to put in 3x plus 15 in for AB, and I'm going to put in 5x plus 7 in for AC, which was making a substitution. We substituted something equivalent to AB, which was labeled on the diagram. Our next step would be to simply get our x's on one side, so we would subtract 3x from both sides. If you heard a sound difference, the air just went off. And that would be by the subtraction property of equality. Oops. Next, we would also subtract again because we need to get the variable alone. So isolate the 2x, we need to subtract 7 from both sides, giving us 8 equals 2 times x. Remember how many times I said over and over again that it does not matter what side your variable is on. Oops, I guess I don't need 2 r's when I write subtraction. So dividing by 2 in the next step gives us 4 equals x. That's by your division property of equality. And then finally you turn it around using our symmetric property, which is why I say it doesn't matter what side x is on. The symmetric property allows us to say then that x is 4. Okay, number 9 is quite similar to the one that I just got through doing in some ways, except that now we're working with angles. So we've been given a diagram with 2 angles, MPN, and NPQ. Those angles are said to be congruent. I could mark the diagram. But I also want to say their measures then are equal. So the measure of angle MPN is equal to the measure of angle QPN. And that would be by definition of congruent. Now I'm not talking about segments anymore. I'm talking about angles. So definition of congruent angles. Now I'm going to trade the measure of angle MPN for what's labeled in the diagram an x plus 26. And for the angle QPN, I'm going to replace it with a 2x plus 10 by doing a substitution. Next, I'm going to subtract x from both sides, giving me 26 equals x plus 10. And that was my subtraction property. And then I would subtract 10, giving me 16 equals x. I did another subtraction. And then I would turn it around by the symmetric property of equality, or symmetric property, and say x is 16. Okay, this next proof is on segments. I'm going to just fill in my givens as usual. Okay, and what it's telling me is that segment SC here is congruent to HR, and then HR is congruent to AB, which was given. I can drop the bars, the segment bars in the similar symbol to get that SE's length is the same as HR's and HR's length is the same as AB's by definition of congruent segments. We also can say now, based on these two statements, we're taking 1, 2, a third thing, and we're putting the first and third together, which would be our transitive property. Okay, so now we can say that SC equals AB, and therefore the segment SC is congruent to segment AB, which is what we wanted to prove, and that has to always go in the last slot by definition of congruent segments, and you can write segs. Last one, I did help the students start up this problem because I was concerned that some people may not understand what the multiplication property is saying. If you multiply both sides by x plus 3, so essentially we're doing this by multiplication property, that would cancel out the x plus 3's here, and you'd end up with 4 equals 4 times in parentheses x plus 3. So you multiplied by x plus 3 on both sides. That is the multiplication property. The next step, they went ahead and distributed the 4 times the x plus the 4 times the 3 to get 4 equals 4x plus 12. Distributive. I need to spell instead of talk. Our following step would be to subtract 12 from both sides, giving us negative 8 equals 4 times x. Now, most of our students are very excellent at solving equations at this point. They learned it in Algebra 1, but also we've been doing it a lot. We get negative 2 is equal to x, which would be by the division property. And then finally, you can turn it around and say that x equals negative 2 by the symmetric property. Of course, you can pause if whatever you'd like to do, rewind if I went too fast. After that, today, I usually go over the 2.7 questions and possibly 2.6. Have a great evening. Timer time is out.